We're at gotomath.com. Click on the algebra. Let's go down to reducing rational expressions. And looks like we're starting off with 1.1. Reduce the rational expression to lowest terms. Lowest terms. So I'll need to write this down. 7x squared, y to the 7th, over 10x cubed, y to the 11th. Okay. Got it. So we have 7x squared, y to the 7th, over 10x cubed, and y to the 11th. So hopefully you have been through the previous section, and that had to do with integer exponents, these guys here. Okay, so it's pretty important that that you understand the previous section before you even get to this one here. Okay. All right, so and since that's said, we're not going to go through, all the steps to simplify this. We're going to kind of skip some steps, okay? So it looks like 7 and 10, there's not a number that will go both into 7 and 10 other than 1, so that's not going to reduce down any. However, we have 2 x's in the numerator and 3 x's in the denominator. So we can cancel 2 of the x's out in the numerator up here, and we'd just be left with 1 x down in the denominator. Of course, I'll be rewriting the 10. And so we have 7 up here in the numerator, 11 in the denominator. So we can cancel out all 7 here. And what will we have down here? It looks like 4. So y to the 4th. Now, that's what I mean by we're not going to be going through the full steps like we did in the previous section. I'm going to expect that you know how to do that. However, for this particular video here, I will go through some of the steps. So remember, we brought this up into the numerator, and the exponent becomes the opposite sign. So if it's positive here, we bring it up, it then is negative, and we add the exponents. So you end up with 7x to the negative 1, and then y to the negative 4. Right? Negative 4. Okay. And so, of course, we don't leave it with negative exponents. We write our answers with positive exponents. So you would take this back down into the denominator. However, we're not going to be going through this procedure every time now. We're just going to go from here basically to here. I'll explain how we're doing it. And okay, the only reason I rewrote this was because to scoot that 7 over a little bit. Alright. Okay, so we have 7 over 10x. And what you're going to see if you have to put this in the green check boxes, we'll definitely have to put a parentheses around the bottom of this. Alright, and the reason for that is the order of operations. What would end up happening is the 7 would be divided by 10, but then it would end up taking this and multiplying it by x and then times y to the 4th. Okay, so that's the reason why it's important to put parentheses around the bottom. All right. Okay, so now that all that's said, let's get back to the answer here. And did I write the problem down wrong? X to the 12th. Oh my gosh. Looks like I might have written the problem down wrong. I've forgotten, left off the, boy, that figures. I left the 1 off there. That should have been a 12. Anyway, so as you can see here, there's 3 x's down in the denominator, 12 up at the top. So subtracting 3 off of the top, we'd end up with 9 of them, right? And then, of course, that looks like that's correct. Correct there, I'll be darned. Okay. Enough said on this problem. Alright, so we're over here at gotomath.com. Got to get the problem written down correctly the first time around. Don't know. Alright, see you in the next problem. Bye. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to reducing rational expressions. And let's do 1.2. 1.2. Okay, so we got 20x to the 12th, y to the 7th, over 12, x to the 3rd, y to the 12th, and then we got this negative z to the 7th. Lovely. Alright. So 20x to the 12th. I feel like a deja vu moment coming on there. Y to the 7th, considering that's what we were supposed to write in the last problem. And then down below we've got 2x cubed. And actually, that was an x cubed in the last problem. How bizarre. Y to the 12th, what's the probability of that? And then negative z raised to the 7th power. Okay. So first thing, we can do some stuff here. We got 2 goes into 20 10 times. Alright. Now, let's take a look at this without having to go through all the long steps on this. You got 12x's in the numerator and 3 in the denominator. So we can cancel 3 out in the denominator and cancel 3 out in the numerator. And that's going to end up being left with what? 8? No. What am I thinking? 9? 9. X to the 9th. You see that? And then we've got 7 y's in the numerator, 12 y's in the denominator. We're going to cancel one of those out, or cancel all 7 out up here. And so what are we going to be left with down here in the denominator? You're going to be left with a y to the 5th. There'll be 5 y's left. Now let's take a look at this tricky little sucker here. Now remember, we talked about this earlier. If I had negative 1 raised to an odd power, that's going to end up giving me negative 1. Okay. Now I know depending on what z is, z could be a negative number, but let's not look at it that way right now. Alright. So anyway, okay, so we can break this up, and then what we're going to end up doing here is taking this negative 1 and let's just bring it out front. Okay, we'll put it right there. So that becomes z to the 7th power. Alright, z to the 7th power. Okay, I believe that's it. What is going on here? 20 and 12. What, am I like losing my mind? What is going on with this 12? It's driving me crazy. I don't know. I'm seeing 2's here. This is weird. Alright, we got to rethink this here real quick. This part. I once again didn't write enough information down. We got, let's see, 4. 4 goes into 25 times. 4 goes into 12 3 times. Okay? Yeah, negative. What are we at here? Negative, let's see, 5x to the 9th, 3y to the 5th, z to the 7th. Okay. What is going on with these 12s? Ones are disappearing. Anyway, we're over here at gotomath.com getting it figured out. See you in the next problem. Let's go down to rational, or reducing rational expressions. We're doing 2.1. Man, look at all that mess. What a mess. Okay, so hopefully, oh my god, I wrote x to the 12th down on my paper. Something is up with that. Y to the 4th minus 4 x to the 16th, y to the 3rd over 3x to the 8th, y to the 11th plus x to the 8th, and of course the cursor's in the way as usual, and y to the 10th. Alright, so let's see what we can do here. I need to actually make sure I wrote everything down correctly. My track record so far is not good with this section. X to the 15th, y to the 4th, negative 4x to the 16th, and y to the 3rd. Okay, now all we got to do is write it down. X to the 15th, y to the 4th. It's ridiculous. I mean, the lighting, my setup here is not very good right now. I'm in the dark, kinda. Y to the 3rd. Okay, 3x to the 8th, y to the 11th, plus x to the 8th and y to the 10th. Got it. So what are we trying to do here? Reduce the rational expression to lowest terms. Okay. It looks like what we're going to be doing here, it looks to me like we're going to be pulling out some stuff. We got an x to the 15th, an x to the 16th. So you always pull the one out that has the smallest exponent. Okay. So we're going to be pulling out an x to the 15th, it looks like. We have a y to the 4th and a y to the 3rd. So we're going to pull out a y to the 3rd. Okay, start parentheses. So we pulled out all 15 in there. We pulled out a y to the 3rd, so we're just going to be left with one y. And then, okay, so we got a 4 here. And we pulled out 15 of the x's. There's 16 here, so we're going to be left with one of them. Alright, so far so good. Let's take a look at the denominator. Okay, so we have 8x's, we're definitely going to be pulling out 8x's. We have 11y's here, 10y's, so we always pull the one out, smallest exponent, start parentheses, right, we didn't pull the 3 out. Pulled all 8 of those out, we're going to be left with just one y, and then plus, right, and it looks like a 1 right here. Yeah, pulled all 10 of them out, so we're left with that. Now look at here, this is where we're going to be doing the canceling. You know what, we'll just rewrite it right here. So we have 15x's in the numerator, 8x's in the denominator. Cancel all 8 out in the denominator, and we'll be left with 5, 6, 7 x's in the numerator. And then we'll pull out all those, and we'll be left with what, 7y's. Alright. And then we got y minus 4x over 3y plus 1. Okay, so there you go. And where are we at here? No, that's it. Wait a minute. Okay, I think that's it. That's too long, man. Let's see, what did I end up doing? It looks like I ended up multiplying this back inside. X to the 7th times y, didn't leave it in the factored form. X to the 7th times y minus 4x to the 8th. Right, multiplying this back in, 4x to the 8th, this would be 3y to the 8th plus y to the 7th. Yeah, so I went ahead, after we did the canceling stuff, I went ahead and just distributed it back across. Okay, and got it back out of the factored form, it looks like. Alright. Okay, so we're over here at gotomath.com, working on it, and see you in the next problem. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to reducing rational expressions And it looks like 2.2. That's what we might be doing. 2.2. So we have x to the 11th minus x to the 10th. It's over xy to the 4th minus y to the 4th. Okay, let's see what we got going on here with this problem. It's the 11th minus x to the 10th, and it's all over x y to the 4th minus y, looks like y to the 4th again. Let me make sure about that. Yeah. Okay, so let's pull something out of our hat here. After a while, you'll be able to just look at this. You're like, I don't even think, what? This thing don't factor to nothing. Pulling out y to the 4th. Oh my God. Something's going on here. I don't know. I better just trust the math. I'm looking at this going, I don't see how this could factor to anything or reduce. Pull out 10 x's. It's a trick. It's a trick. Pull out 10 x's. What do we get? We get an x minus 1. Oh, I see it now. Wow, that's tripping me out. And so y to the 4th, I got these alien friends that live under the ground in Area 51, and they work these problems, make these problems up for me. Okay, so you see what happened here. If you distribute the y to the 4th back across, you get y to the 4th x, right, or x y to the 4th, and y to the 4th y. Okay, and then of course same thing here, x to the 11th, and then negative x to the 10th. I'm like looking at this going, yeah. So as you can see, those guys are going to cancel out. We're going to be left with an x to the 10th over y to the 4th. Tricky. These people are tricking me. Alright, so we're over here at gotomath.com getting tricked. And see you in the next tricky question. Next problem. 2 blue O's and a red G. You think there might be a cryptic message in there somewhere? You never know. I kind of like doing that kind of stuff. Let's see, we're doing 3.1. Speaking of, I got a contest going on Pi Day on the main page of the YouTube channel. I think I'll do this annually. Anyway, we'll see what happens. There's a cash prize. The first person who can decrypt the message we're going to see how that works out. I'm sure there's some pretty smart people out there who's going to figure it out. I'm sure of it. Yes, and I did use a bunch of had to write a bunch of math equations to do it. So, believe it or not, there is some useful things in the world you can use this stuff for. Alright, so I got this, hopefully you're all written down right. 10x to 6y squared. Z minus x to the 6y squared. 10, I'm just making sure I wrote it down all right. Okay, got it? Alright, good. Alright, so we have 10x to the 6th y squared z minus x to the 6th y squared. It's all over. Got x to the 12th, y to the 4th. Z minus x to the 12th and y to the 4th. Alright. Well, what can we do here? We got a 10 coefficient, but we have a 1, so we're not going to be able to factor anything out there. We have 6 x's and we have 6 x's, so we can pull x to the 6th out, that's for sure. Be left with that 10 right here. You know what? I didn't leave enough room for the next person, or the next person. We've got a y squared and a y squared, so we're going to factor out that y squared. So we're going to be left with a 10, it looks like. We pulled out 6 x's, and oh, we got a z left. I didn't even see that. Minus, so we pulled out 6 x's and 2 y's. Alright, so there you go. Now let's look at the denominator. We got 12 x's, 12 x's, 4 y's, 4 y's. Okay, so we're going to pull out 12 x's and 4 y's. And that's going to be 10z. Minus 1 also? That's kind of freaky. Huh. Okay. So those will cancel out. I don't know why I'm so darn surprised about that. So what are we left with here? We've got 6 x's in the numerator, 12 down here, so we're going to cancel all 6 out, and we will be left with 6 x's in the denominator. Y's, we got 2 y's up here. Looks like we're going to end up just with a 1, and then subtract out 2 y's down there. Alright, so we got 1 over x to the 6th, y squared. And remember, if you're putting this, whoa, didn't mean to do that. That's like top secret stuff. If you're putting this in the green checkbox, you want to put parentheses around this. If not, it'll end up reading, you know, that's not supposed to be an x there. See, if we don't do that, what happens is really, technically, it'll go 1 divided by x to the 6th and then times y squared. Do you see that? So that's the reason you need to put a parentheses around the bottom part here. Okay? Alright. So if you was typing that into an algebraic calculator or any kind of algebraic system, that's the way it would read it. So you have to put parentheses around that. Presidents. What have we got? Answer? Is that what we need to do? X is 6, y squared. Of course, if you're writing it like this is fine. Okay, but if you're linearizing it, right, you want to write it like that. Parentheses around it. Okay. So we're over here, go to math. We're learning a little math, a little algebra. This is probably one of the most important courses that you can learn, believe it or not. And of course, geometry is a very important course. If you're going to go on to study theoretical math, learn how to do proving. But there we are. Okay, I think we're done. See you in the next problem. Click on the algebra. Let's go down to reducing rational expressions. And what are we doing? That's the question, I believe. XZ, 3Z. Okay, I guess it's that one. Alright. 3.2. So we have xz to the 10th minus 9z to the 10th. Okay. Those two monomials are completely different. xz to the 4th minus 9z to the 4th. Alright. Reduce the rational expression to lowest terms. Okay. xz to the 10th. That's x times z, by the way. Didn't know. Minus 9z to the 10th. And that is all over something. X z to the 4th minus 9z to the fourth. Alright, let's take a look at the numerator. Well, we have an x in this term here, but we don't have an x over here, so we won't be factoring an x out. However, we do have 10 z's, z to the 10th and z to the 10th. So guess what? We're going to definitely pull that out of our hat, and that's what we're going to be left with, right? Over, alright, let's take a look at what we got down here. We have an x, but we don't have an x over here. But we have 4 z's and 4 z's. We can pull out some z's. We'll pull out 4 of them. And we'll be left with x minus 9. We have an x minus 9 in the numerator, 1 in the denominator. So we can simplify that. Now look at here. I know this is over rational expressions, but this guy reduces down because we've got 10 z's in the numerator, 4 in the denominator. We can cancel all 4 out in the denominator, cancel 4 of them out in the numerator, and we will be left with z to the 6th. Z to the 6th. Wow, that reduced down, didn't it? Who would have known? Who would have known? There you go. Okay, so we're over here at gotomath.com, working it out. See you in the next problem. So this is where we are, and this is where we're going. Reduce rational expressions. Looks like 4.1 might be our target. Okay, so I'm going to write this down. X plus 10 over x squared plus 17x plus 70. Uh-oh, we're back to factoring quadratics again. Oh my gosh. So x plus 10 over, how do you like that line? X squared plus 17x plus 70. Plus 70. It looks like we're going to need to factor the denominator. So once again, we got two numbers that when multiplied together gives us 70, and when we add them, we get 17. Now remember, we need to take a look at this 70 here. So what do we got? We got 70 and 1. Probably not, right? 71 is not going to give us 70. But let's break this down. We've got 7 and 10. Look here. 7 times 10 is 70, and when we add 7 plus 10, we get 17. Put an equal sign there. So we got, okay, what's going on? What was that all about? Alright, so this thing's going to factor, right, to 7 and 10. Should have known one of these guys was going to factor. So we can cancel out that x plus 10. We got 1 in the numerator, 1 in the denominator. And so now we are left with just 1 over x plus 7. How do you like those beans? 1 over x plus 7. Is that how that's supposed to go? Beans. How do you like those something? Alright, 1 over x plus 7. There you go. Look at that. Isn't that much nicer? Alright. What are we doing? Tell you what we're doing. Get back to the page there. We're gotomath.com. Come on by, check it out. See you in the next problem. Click on the algebra. Let's go down to reducing rational expressions. We're looking at 4.2, it looks like. We have negative x minus 9 over x squared plus 14x plus 45. What do you know? Who would have known? Negative x minus 9 over x squared plus 14x plus 45. Okay. Well, what I'm going to do here is I got a feeling we're going to be factoring out a negative 1 up here, but let's take a look at this down here. Let's factor this if we can. So we got 45. need to look at. So it's either going to be 1 and 45 or 9 and 5, probably. So we need two numbers multiplied together, gives us 45, and then when we add them, we get 14. And guess what? It looks like that guy right there, doesn't it? All right. And okay, let's just go ahead and rewrite this up here like that. So we end up with that's set up. We end up with 9 and 5, or I'm going to write 5 and 9, it doesn't matter. Okay. But nothing's canceling out here, so something must be fishy, right? Let's go ahead and pull out a negative out of there. So we end up with x plus 9, and that's going to be over x plus 5 times x plus 9. Now, you can see it, right? These guys are going to cancel out, and we're going to be left with, right, that's it, right? Okay, 1 over x plus 5 it looks like. I mean, you look at that, you're like, how could that ever be 1 over x plus 5? Take my word for it, it happened. Well, it's negative 1 over x plus 5, reduced down to. Alright, so we're over here, gotomath.com, getting it worked out. Come on by, check it out, practice. See you in the next problem. Hey, we're over here, GoToMath. Click on the algebra. Let's go down to reducing rational expressions. We are doing 5.1. We're at the midway now. At the midway point. Well, almost at the midway anyhow. Okay, we got x squared minus 18x plus 81 over x squared minus 11x plus 18. I'll tell you something I noticed earlier, and I need to go in there and look at the programming, but I was clicking through this before I started making the videos of this stuff, and I was clicking, and it turned out that this top polynomial was the same as the numerator was the same as the denominator. And obviously if that happens, you know, you just cancel them both out and the answer is 1. You may run into that. If you do, just click and get a new problem, okay? But because it's not going to be totally reduced completely down. Like for example, the answer might end up being x plus 1 over x plus 1, but obviously that would cancel out to 1. Alright, so that's something I need to go back and take a look at. Alright, I thought I would throw that in there at you there. So we have x squared minus 18x plus 81. Yeah, I don't know how that slipped by me. Not sure. X squared minus 11x, you know, what is the probability? How often is that going to come up? Where the numerator's same as the denominator. Look here, these are both been reversed, them digits. Okay, so let's go ahead and factor the numerator, factor the denominator, cancel out some stuff. Alright, so let's go ahead and work on the numerator first. Okay, so we'll write down 81, and we got 1 and 81. We got 9 and 9, which I got to fill in 9 and 9 because 9 plus 9 is 18. Okay, so we're looking at two numbers that when multiplied together gives us 81, and when we add them we're going to get negative 18. We get negative 18. Okay, and so it looks like that this is going to end up, the numerator is going to be x minus 9 times x, I guess, minus 9, right? Negative 9 is positive 81, and when you add them, you get negative 18. Okay, good enough. Alright, let's take a look at the denominator. So we have 18's the number, so it's going to be 1 and 18. Now, of course, we got a negative 11 here, so that's probably not going to be it. What else we got? We got 6 and 3. No. Let's see, 2 and 9. Yeah, 2 and 9, if we add them, we get 11. So there you go. All right. So hopefully you're catching on to that factor in these guys. And you're going to get 2 and 9, and of course they're going to both be negative, because negative 2 times negative 9 is positive 18. Negative 2, add that to negative 9, and you get negative 11. All right. Well, those guys are going to cancel out. That's the good news. And we should be doing this. So we have x minus 9 over x minus 2, it looks like. This thing's going to reduce down to x minus 9 over x minus 2. All right. That's where we go to math.com. Come on by practice. All right, if you can. And unfortunately, it works best in Chrome. Okay, for some reason. Who knows? All right, talk to you later. See you in the next problem. Okay, let's go up to the algebra, go down to reducing rational expressions, and we're looking at 5.2. Okay, this looks like some good numbers there. So we have negative x squared plus 14x minus 49, and it's over x squared minus 9x plus 14. Alright, so bring up the whiteboard. We got negative x squared plus 14x minus 49, and that's all over x squared minus 9x plus 14. And I'm not exactly sure what happened there. Okay, so the first thing I'm going to do is pull this negative out of here. So let's do that. So we're left with an x squared minus 14x and then plus 49. Okay, so the signs change. Now let's go ahead and factor this. We've got 49 here. Two numbers multiplied together to give us 49. And when we add them, we get negative 14. So let's take a look at this. What about 7 and 7? Obviously 7 times 7 is 49, and when we add them we can get 14. Okay, so it looks like negative 7 and negative 7. And now let's take a look at the denominator here. 7, 8, 9. Looks like this one here is going to be, I think we can do this. I'm going to write all that out. Let's look at this. We've got 14, so if we did 7 and 2, 7, 8, 9. If we did 7 and 2, right? 7 times 2 is 14, and if we made this a minus and this a minus, right, negative 7, negative 2 is negative 9. Okay, now let's do some canceling here. We can cancel these two guys out, and what, I should write an equal sign here. And so what's going to be left? Well, we're going to have this negative 1 times this x minus 7. We're going to go ahead and distribute that negative 1 across. And so, hang in there, this is going to end up being, if I distribute this across right here, we'd have a negative x and a plus 7, but let's just reorder that. Right, over, scroll down there, x minus 2. X minus 2. See that? Okay. Now, further on in, we start talking about functions and so forth, and domains and all that kind of stuff. would actually have to state out here something about that this is actually equal to this, but in order for this to be equal to this, both their domains must be equal, and we'd have to state something about that x can be equal to 7, but that's not really what we're doing here in this section yet. So we got a lot to talk about before we can actually get to that. Alright, and let's go over here. Let's click on, okay, so it looks like I didn't take the negative and distribute it across, or this would end up being 7 minus x. That is an x minus 2 in the bottom, yeah. Alright, you never know. Okay, so we're over here at gotomath.com figuring it out. See you later. See you in the next problem. Okay, we're here at gotomath.com. Click on the algebra. Let's go down to reducing rational expressions. And we're looking at 6.1. I hope. Reduce the rational expression to lowest terms. Alright, so it looks like same song and dance. We got x squared plus 8x minus 20 over x squared plus 9x minus 22. Okay. What are we doing here? Let's go here. So x squared plus 8x minus 20, and that's all over x squared plus 9x minus 22. Alright, so let's factor the numerator. And let's start now skipping steps, okay? Alright, so we're going to put an x here, an x here. Two numbers multiply together gives us negative 20. When we add them, we get 8. What about 10 and 2? What about 10 and 2? Let's put a 10 here and a 2 here. We know that 10 times 2 is 20. We also know that if we subtract 2 from 10, we get 8. And therefore, this would have to be a negative, and we'll put a plus sign here. See that? That was pretty easy. Okay, so up to this point, you should be able to do that. We've been going through a lot of intermediate steps on factoring these quadratics, but it's now time to start skipping steps. So what about 22? What about 11 and 2? 11 and 2. 11 and 2, right? We know that 11 minus 2 is 9, and we also know, so we'll have to go minus here and then plus. Right, and 11 times 2 is 22. And something else we should do is kind of write this. But now what we should do is let's cancel some stuff. So x minus 2 in the top, x minus 2 in the bottom. Okay. So now we're left with an x plus 10 over an x plus 11. There you go, x plus 10 over x plus 11. So let's take a look at what we got. X plus 10 over x plus 11. Alright, so we're over here at gotomath.com, and I'll see you in the next problem. Click on the algebra. Let's go down to reducing rational expressions, and we're looking at 6.2. 6.2. So let me spend a second here and write this down, and hopefully you're doing the same thing. Alright. Okay. X squared plus 5x minus 14, and that's all over negative x squared minus 6x plus 16. Alright, so we're probably going to end up factoring out this negative, a negative out of here, negative 1, and but let's just go ahead and take a stab at the numerator. Alright, so we're getting to the point now where we're starting to skip some of the intermediate steps. Alright, Two numbers multiplied together gives us 14, but when we add them we get 5. Well, let's take a look at 7 and 2. Right, 7 and 2. We know that 7 minus 2 is positive 5, and 7 times negative 2 is 14. Alright, so that's good. Now what we're going to do here is I'm just going to do a little side work over here, and we're going to factor out that negative. So that's going to make that x squared plus 6x and then minus 16. Okay, so two numbers that multiply together to gives us negative 16, and when we add them we get 6. Let's see, what about 2 and 8? Let's put an x here and an x here. 2 and an 8, right? And so this is going to be a plus 8 and a minus 2, because 8 minus 2 is 6, right? And negative 2 times 8 is 16, negative 16. So now what we can do is some canceling. We'll cancel those guys out. Now we're left with x plus 7 over x plus 8. So if you could see that. Okay. X plus 7 over x plus 8. Oh. And, wow, I just about made a mistake. We factored that negative out. Let's just put it right there. Okay, it was down here in the bottom, right? We just move it right out here. Okay. You could also, if you wanted to, you could take this negative and bring it in up here. No, you wouldn't want to do that. Never mind. Because then that just makes that negative and that negative. So we'd leave it out. Alright. So there you go. We are, where are we? We're over here, gotomath.com. See you in the next problem. Okay, click on the algebra. Let's go down to reducing rational expressions, and we're going to be looking at 7.1. Okay, so let's get this one written down here. 2x squared plus 16x plus 24. So you should be getting the hang of factoring this stuff by now if you've been working in the previous sections. Plus 60. Right. 2x squared plus 16x plus 24. And that's all over 2x squared plus 22x plus 60. Alright, so we take a look at this coefficient here. We got a 2. Now the question is, can we factor this 2 out? 2 goes in 16, 2 goes in 24, and yes we can. What about down here? 2 goes in 22, 2 goes in 60. So let's go ahead and factor this 2 out. Alright, so we got x squared plus 8x plus, and that'll make that a 12. Alright, that'll just be a whole lot better when we go to factor this thing. So same thing here, we got x squared plus 11x, and then that looks like that's going to be plus a 30. Alright, well, good news is those two guys cancel out, so we can get rid of them. Now let's take a look at the numerator up here. So this ought to be pretty easy to figure out. Two numbers multiplied together gives us 12, and when we add them we get 8. What about 6 and 2? Of course that's going to be a plus and a plus. Right, 2 times 6 is 12, and add them, you get 8. Okay, good. Now considering probably something's going to be factoring or canceling out, you know that one of these is going to be a 2 and the other is going to be a 6. I mean, that's kind of a given there. And so what about 6 and 5? Right, 6 and 5. Let's see, what are we doing? We're looking at this number. 6 and 5 is 11. Yep, that looks like that might be it. See that? 6 times 5 is 30. When we add them, we get 11. Okay, so those guys are canceling out. Now we're left with x plus 2 over x plus 5. That divider there has gotten in the way. All right. So x plus 2 over x plus 5. Yeah, well, they're equal. But we got to state it, something. We're not getting into domain just yet and all that kind of stuff. That's later on. But we'll just say they're equal. Okay. Okay. Let's click answer here. X plus 2 over x plus 5. There you go. All right, so we're over here, go-to-math.com. I'll see you in the next problem. Okay, we're over here, go-to-math.com. Click on the algebra. Let's go down to reducing rational expressions. And you know what? I'll just click on that and look what comes up. All right, so let's write this one down. We have negative 5x squared minus 27x minus 28. And that's going to be all over negative 5x squared minus 22x minus 21. Alright, so rewriting all that. Minus 28. And that's going to be all over negative 5x squared minus 22x minus 21. So the first thing I'm going to do is go ahead and factor out this negative. We can do that. And you know what? Let's just write it over here. So negative 1, so we're going to factor that out. We're going to end up with 5x squared plus 27x and then plus 28. And then of course we can do the same thing down here in the denominator. So we have 5x squared plus 22x and then plus 21. Okay, so as you can see here, these negative ones are going to cancel out, so that's good. Alright, so let's take a look at this this top guy up here, and we may go through some of the intermediate steps on problems like this. We're looking for two numbers. When we multiply them together, we get 28. Now, and I'm going to go ahead and write this out for right now. Okay. And we're going to call this A and this one B here. Okay. So A times B is going to give us 28. But now we got 5x times B and then plus A times X. So 5 times B plus A is going to be equal to, we better be looking at this one here, huh? Or this one, I mean, is equal to 27. Now let's take a look at 28. We got 1 and 28, right? Well, we know that 1 times 28 is 28, and we also know that 28 minus 1 is 27. It's 27. So, wait a minute. We got this 5 right here. Never mind. Oh, man. So 5 times, let's see, 1 plus, yeah, so 5 times 1 is 5 minus 28 is not 27. So we're going to need to break this down a little more. Okay, so what about 2 and, what is this, 14? 2 and 14. So let's see, 5 times 2 is 10, and 10 plus 14 is 24. And that's not going to work. Nope. And so what about 4 and 7? 4 and 7. So 5 times, okay, here we go. 5 times 4 is 20 plus 7 is 27. There you go. So B is going to be 4 and A is going to be 7. How about that? Right? So you have 5x, that's going to be 20, then 27, and 7 times 4 is 28. Okay. So sometimes skipping the intermediate steps could cause you some serious headache. So that's going to be the top one, right? That's going to be the top one. Now let's take a look at this guy right here. And so that's we'll do our side work over here. So remember, we're looking for two numbers that multiply together to give us 21, and then of course we're going to do the same thing here. We got 5x, x, so we're going to have 5 times b plus a is equal to, you can't see that probably off the screen now, it's 22. Right, is equal to 22 here. Okay, so what number are we working with? Remember, 21 is going to be that key number. So we got 1 and 21. We put a 1 here, and then 21 here. Now that's going to be too big, isn't it? So what about 3 and 7? We know if we put a 3 here, that's 15, and then a 7 here, that is going to be 22. There you go. So B is 3. And what are we considering to be B? This guy right here. Right. That's going to be 3, and that will be, A will be 7. 3 times 5 is 15, plus 7 is 22. Alright. I hate to erase stuff, and it's not a good practice to erase, but alright, so here we go. We can now cancel some things out. We have 5x plus 7, 5x plus 7 down in the denominator, and we're going to be left with an x plus 4 over an x plus 3. And of course, remember, our negatives canceled out, so there you go. X plus 4 over x plus 3. Alright, that took a little time there, didn't it? Alright, so we're over here at gotomath.com, practicing some factoring. See you in the next problem. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to something here. Where are we at? Using rational expressions, and I believe we're doing 8.1. Okay, so reduce rational expression lowest terms. Alright, so we got 4x squared minus 23x plus 33, 5x squared minus 11x minus 12. Alright, well, let's write that down real quick here. Okay, got it. Alright, so we got 4x squared minus 23x plus 33 over 5x squared minus 11x and minus 12. So it doesn't look like we can factor anything out. We've got a prime number here, so I'm not going to be able to factor anything out here. What about the bottom? And it doesn't look like we're going to be able to factor anything out there either. So we're going to take a look at the top here, and I'm going to start with a 4x and see what happens. So remember, we've got 4 can be broke down to, definitely not that, 1 and 4. 1 times 4 is 4, or we could break it up to 2 and 2. Okay, and we'll start with 4 and 1 here. Now 33 is 1 and 33, or let's see, 3 and 11, right? So remember, we got two numbers. When multiplied together, it gives us 33. And then, of course, if we're going to let this be A and this be B, right, you're going to have 4 times B plus A is going to be equal to the negative 23 here. Negative 23. Okay. Now let's take a look at this. If I put 4 times 33, that's a huge number. So we know that's not going to be it. Or if it was 4 times 1 and then a 33, that's not going to give us a negative 23. So we're going to have to look at 3 and 11 here. And remember, one of them's going to have to be, no, wait a minute. And we got a positive and a negative. They're going to have to both be negative, right? So if I put a negative 3 here, we get negative 12. And what about an 11? 12 and 11. Yeah, 12 and 11 is 33, right? No, negative 23. 12 and 11. 3, yeah, 23, that's it. There you go. Okay, that wasn't too bad. So that's going to be, hold on, I've already forgotten here. Let's see, 12 and 11. So B will be the 3, and that will be the 11 here. Alright, so that wasn't too bad. Let's get rid of that. Whoops, didn't mean to get rid of all of it. Okay. Now let's take a look at the denominator. I'm going to go ahead and start with a 5 here. Well, that's really the only thing we could put here is a 5. Actually, can't break that down anymore. So if this is an A and this is a B, and of course, what do we got? We got 12. So let's take a look at that. We got 1 and 12, or what else? 4 and 3, or 4 and 3, right? So, actually, let's just look at this here. 5 times 4 is 20. We've got to do a negative 11 here. 25 times 20 and 3, 23. No. Let's see. If this were, hell, the only other choice we got here, as long as 4, 3, 15, and 4 is negative 15. Oh, negative 15. And for this is a minus and that's a plus. There you go. So you got negative 15 and plus 4 is a negative 11. Ugh. Whoops. Get rid of that. And I got rid of everything. 3 and 4. Okay. So obviously these guys here cancel out and we're left with a 4x minus 11 over a 5x plus a 4. Okay. So let's click that. 4x minus 11 over 5x plus 4. Alright, good thing. Okay, so we're over here at gotomath.com and see you in the next problem. Click on the algebra. Let's go down to some reducing rational expressions, and we're looking at 8.2. Working our way right on through. Hey, that kind of rhymes. Alright, so we got 3x squared minus 23x plus 40 over negative 5x squared plus 19x plus 30. Alright, so 3x squared minus 23x plus 40 and negative 5x squared plus 19x plus 30. So we take a look at the top here. Wow, we get another 23. We got one of those last time. Okay, so it doesn't look like anything's going to factor out here, and not in the bottom either. Alright, good news is the only numbers that will go into 3 is 1 and 3, so we know this will be a 3x here. So that's good news. Alright, and so we have a 40. Let's take a look at this. So it's going to be 1 and 40, 2 and 20. Oh my god, it could be, that's 5 and 4, it could be 10 and 4. Could be a lot of things. This ought to be fun. Alright, so this is our A, and this is going to be our B. Now we got a plus here and a minus here. So what that tells us is this must be a minus, and that's got to be a minus also. Okay, so that's kind of good. So two numbers that multiply together, that gives us 40. And now that we go 3 times B plus A is equal to negative 23. So let's take a look at this. Let's see. We know it's not going to be 1 and 40, right? Because if you put a 1 here, 40 here, that ain't going to work. All right, what about 2 and a 20? Put a 2 here, you get 6. And then, no, that's, let's see, if you put a 20 here, you'd get 60. That ain't going to work either. Remember, okay, 2 here, you get 6. That'd be 26. Yeah, that's not going to work. All right, let's take a look at 10 and 4. If you put a 10 here, that's going to be 34. No, that's not going to work either. Remember, both these must be negative numbers. Put a 4 here, you get 12. Okay, I think that might be it. So if you put a 4 here and a 10 here, you're going to get 12, and 12 plus 10. Oh, crud. It's 22. That is terrible. Okay, well, we got to be running out of options here. So that's not it either. 22 times 5. What are all the possibilities here? It seems like we've going through them. 2, 5, 2, 2. 10 and 4. Okay, wait a minute. 8 and 5. It's got to be 8 and 5 or 5 and 8. 8 and 5. That's going to be 24. And, okay, so it's got to be 5 and 8. We got no other choice. We got to stay focused on what we're doing here. Negative. What did I say? 5 and 8? 5 and 8. 15 and 8. There you go. Man, I didn't think I was ever going to get that. So 5 and 8. 3 times that is going to be negative 15. Negative 15. And then minus 8 is negative 23. And then that times that is 40. Oh my gosh. That took way too much time. Alright, this one here, we're going to go ahead and factor out that negative. So that's going to be 5x squared minus 19x minus 30. Hopefully this one won't be as bad. Alright, but good news is we got a 5 to deal with, so that's the good news. In other words, we don't have any other numbers to deal with on that coefficient. Alright, you know what? I'm just going to erase this. Hopefully you got all that. Get rid of all that scratch. Okay, so we're looking at this one here, and, or no, we're looking at this one, aren't we? Alright, 30. 1 and 30, 2 and 15, 3 and 5, so that's going to be 6 and 5. Okay, I think that's going to be it. Okay, A times B is equal to negative 30, and we're going to have 5 times B plus A, and that's going to be equal to negative 19. Alright, so if we looked at 1 and 30 here, 1 and 30, okay, that's not possible. 30 and 1, no. Let's take a look at these signs here real quick. We got a negative, so one of them is going to be negative, and the other is positive. Okay, well that's not good. What about 2 and 15? Plug a 2 in here, you get 10, and then 15. No, that's not possible. What about 15? No, that's going to be too big. Okay, that's gone. So it's got to be 6 and 5. Put a 6 in here, you get 30 and 5. No, so it's got to be a 5 here. A 5 and 6. We've got no other choice. So that's going to be 25 and 6. And dadgum. Yeah, 25 minus 6 is 19. Whew, that was close. Okay, so B is going to be negative. B is a negative 25, and why did I write a 6 here? I don't know. Wait a minute. Oh, it's 5 and 6, yeah. So this has got to be positive 5. Wait a minute, I got that backwards. That can't be right. Oh, I know what I did. What are we doing here? 25. B is negative 5. Right? And that is 6. Okay. So those guys are going to cancel out, and we're going to be left with a 3x minus 8 over 5x plus 6. Alright. Oh, you know what? I forgot that negative. There was a negative here. One of these numbers is negative, and it's coming from down here. We factored out the negative, so we're going to pull that out and put that right over here to the side. Alright. Forgot about that. 3x minus 8, 5x plus 6. Yep. I do this stuff on the fly. Nothing's worked down in advance. Alright, so see you later in the next problem. Okay, we're here at GoToMath.com. Click on the algebra. Let's go down to reducing rational expressions. And you know what? We'll just click right here. 9.1. Okay. So we got 36x squared minus 49. Got to smell the difference of squares there. 6x squared minus 19x plus 14. Okay. We have 36x squared minus 49. Well, I don't know about that. Let's redo that. That didn't look good. Okay, that's a little better. Then we had 6x squared minus 19x plus 14 in the denominator. So let's take a look at the numerator. Taking a look here. So this looks like this is going to be in the form of ax squared minus b squared. Okay, the difference of squares, and therefore if we had to factor, this would be ax minus b times ax plus b. Right, and that's supposed to be an a there. Okay, so in this particular case here, we've got 6x quantity squared minus 7 squared. See that? Right? So that's going to be, you know what, let's do this. Let's just go ahead and write the denominator here. 6x squared minus 19x plus 14. So up here in the numerator, we're going to end up with 6x minus 7 times 6x plus 7. Now let's look at the denominator. We got a 6, a 19, and a 14, so it doesn't look like there's anything we can factor out there. Now here's a hint. We have a 6 up here, right? So more likely this thing's going to probably start with a 6 than an x. Right? And chances are it's going to be a 7. One of these is going to be a 7 here. Right, if not, we'd have to go through all the possibilities, and that would be a 2 or a 3, or a 2 right here. Right, 2 times 3 is 6, so it's either going to be a 6 or a 2, but we're going to start with a 6 here because, well, we have a 6, right, in this one here, and a 6 in this one, so there you go. Okay, so let's take a look at this. 14. Now, looking at the signs, we have a negative and a positive. It tells me that both of these going to be negative, right? Because a negative times a negative is a positive. Alright, let's take a look at 14. So we got 14 and 1, or we could do 2 and 7. So remember, it's a times b. It's going to be equal to 14. And if we let this be a, you should be getting the hang of this by now, that'd be b. So this is going to end up being 6 times b plus a is equal to negative 19. Negative 19. Okay. So 2 and 7, let's take a look. Now remember, they're both negative. So 6 times, what are we looking at here? Negative 19, right? Actually, it's written here. 6 times 2 is 12. And then 12 and 7, that's 19, right? So if that were a 2, if b is a 2, and a is a 7, there you go. So 6 times 2 is negative 12. Negative 12 minus 7x, that's going to be a negative 19x. And then negative 7 times negative 2 is a positive 14. Alright, let's just get rid of that piece there. Ended up getting rid of everything. So now what we can do is do some canceling. So we have a 6x minus 7, 6x minus 7, and it looks like we're going to be left with, let's write this down here, 6x plus 7 over x minus 2, over x minus 2. Right? 6x plus 7 over x minus, x minus 2. Alright, so we're over here at gotomath.com, getting it worked out. See you in the next problem. Go up to Algebra, let's go down to Reducing Rational Expressions, and we're looking at 9.2. Right. So we have 3x squared minus 35x plus 72, and that's all over 64 minus 9x squared. Alright. 3x squared minus 35x plus 72, and that's all over a crooked line, 64 minus 9x squared. Alright, so we'll take a look at the top first. 3 go into 35, does 3 go into 72? That's the question. And no. Alright, so Let's factor the numerator. We know that it's going to end up starting with a 3x. We really don't have any other possibilities with that. But we got to take a look at 72. We got 1 in 72. What else we got? We know that 9, I think, goes into 72, right? 8 times 9 and 8, 72. This thing could be broken down into a bunch of different things. Let's hope it's 9 and 8. I don't know. Now we know this is a plus and this is a minus, therefore both of these must be, this is going to have to be a minus and a minus. Remember, we're calling this A and this B. So we got A times B is equal to 72, and then 3 times B plus A is going to be equal to negative 35. Right. Okay, well, let's take a look at this. We got 3 times 9 and then plus 8. 27. Now we said both of these are going to have to be negative, so 3 times 9 is 27, and 27 plus 8 is going to give us 35. I think we got lucky on that. So B is, what did I say? B was 9. And A is 8. Right? 3 times 9 is negative 27, minus 8 is negative 35, and then negative 8 times negative 9 is a positive 72. Okay. We'll just consider ourselves getting lucky on that. Alright. Now, taking a look at the denominator, let's just do some side work over here. We can actually rewrite this by factoring out a negative, and that would make that a 9x squared by reordering some terms here, minus 64. See, if I went ahead and distributed this negative inside, we'd have negative 9x squared, and then plus 64, but then we'd write it, right, like this. So let's just keep it like this. Now what do we got? We got the difference here. The difference of 2 squares. The difference of 2 squares. So we can go 3x minus 8 by factoring that, and 3x plus 8. And as you can see, we got a term in the numerator, so it's equal to the term in the denominator, and we're going to be left with, okay, battery's getting low, we're going to be left with an x minus 9 over 3x plus 8. I better hurry up. And remember about the negative here. Don't forget about that. So we'll throw that out front. X minus 9 over 3x plus 8. Yep, threw that up front. Alright, see you in the next problem. Alright, let's go up here to Algebra and down to reducing rational expressions. We are looking at 10.1. If I can get it to come up. There it is. Alright, let's write this down. So we got x cubed minus 27 over 5x minus 15. Got it. X cubed minus 27 over 5x minus 15. Alright, so let's take a look at the numerator up here. This is in the form of the difference of 2 cubes, and so we should remember from a previous sections on how to factor the difference of 2 cubes. Now whatever this sign is, we're going to write the opposite right here. And then we have ax plus, this is always a plus sign, and then that's always going to be squared. Okay, so that's what we're looking at. Now in this particular one here we got 27, and that's equal to 3 cubed, right? 3 cubed. So this is going to end up being x, well, let's write it like this. So this ends up being x minus 3 cubed. Okay, so we'll go ahead and write it over here. So we have x minus 3 times x squared, now we're looking at this one here, plus 3x plus 3 squared, which is 9. Okay, so that's the numerator. Now the thing about the denominator, we've got a 5 here as a coefficient and 15. We can factor out a 5, and we're going to be left with x minus 3. Right. Well, we have an x minus 3 up in the numerator, 1 down in the denominator. And so now what we can do is go ahead and just cancel those out and rewrite. So we got x squared plus 3x plus 9, and that's going to be all over 5. Over 5. All right. Okay. All right. I see something fishy with this problem, but anyway, this is the answer. This is it right here. Okay. Alright, so we're over here at gotomath.com, getting it figured out, and I'll see you in the next problem. Okay, we're here at gotomath.com. Click on the algebra. Let's go down to reducing rational expressions, and we're looking at 10.2. 10.2. So we have x cubed plus 8 over x squared plus 4x plus 4. Okay. And somebody forgot to erase the board last time I was in here teaching class. Well, I tell you what. Okay, we got it. We got it. Alright, so we got the last problem of this section, at least the last problem for a while anyway, till I finish the algebra section. X squared plus 4x, and then come back and add more problems. We need to add a lot of application problems. That's what we need to be adding. Okay, so what do we got here? We got the sum of two squares, x cubed plus a cubed. I think a got a little out of hand there. A cubed. So this can be factored as x plus a times x squared minus, remember this sign here is always opposite of this one, ax, and then plus, that's always a plus, a squared. Okay, so in this particular one here we're going to have x cubed plus 2 cubed, right? 2 cubed is 8. Okay, so we'll go ahead and write that over here now. So we have x plus 2 times x squared plus, minus 2x plus 2 squared, which is 4. And then that's going to be all over. Now we're going to need to factor this guy down here. So let's take a look at this. You should be getting good at this by now. Two numbers that multiply together gives us 4, and when we add them, we get 4. And both these are plus, so we know that this is going to be a plus, and that'll be a plus. Well, more likely it's going to be 2, right? 2 times 2 is 4, and then when we add them, we get 4. Alright, well, we can see here now what needs to be canceled out, and that's what we're left with. So it looks like x squared minus 2x plus 4 over x plus 2 is what we're looking at. Okay. And I almost hit the wrong button there. X squared minus 2x plus 4 over x plus 2. Okay. Looks good. It all looks good. Where are we at? Click this. So we're over here at gotomath.com. That ends this section. So after practicing a few times, you should be ready to move on into the next section, which is, I'm not sure what it is, multiplying and dividing. Okay. See you in the next section. Bye.